right, I want to take another stab at number 19. I tried it by just starting with cosine, but that got so ridiculously crazy. So I thought we'll try number 19, and this time let's just start with our parent function, secant function, and see if we can't make this a little easier. All right, one thing that we can take care of pretty quickly and get out of the way is the amplitude. Remember, this would be a secant bx minus c. And so we know our amplitude is a half, so that we can adjust for that really quickly by just saying this is a half here, and this mark down here is negative a half. If it had just been a half secant x, this is what our graph would have looked like, and we could have just adjusted the numbering on it and kind of, taken care of that. Now, the period, the period is, you remember it's 2 pi over b. Well, our b here is 2. So our period is pi. Okay. So that means it's going to happen, the cycle's going to happen faster for us. So that means it's going to happen in a total of just pi, which basically is going to do this to our graph. I'm already going to have to draw another one because this is going to get kind of crazy. And this is why, and these are a little difficult to graph, these ones with all the shifts, especially when they're the reciprocal functions. Okay, so let's start off with one. Let's say this is our normal asymptote at pi halves, and this is negative pi halves. What's going to happen is that our asymptotes are going to kind of get moved in, and so that asymptote is at pi over 4 now, and this would be negative pi over 4. So let me draw our new asymptotes in and kind of put some numbers in. If that's pi halves, this before would have been 3 pi over 2. That's left over from the one up above, isn't it? Pi halves. Let me just 3 pi over 2, and let's just put 2 pi. So because things are happening every pi now, if this were pi half, let me number in black so it's consistent. If this were pi and this were 3 pi over 2, and let's say I did have 2 pi down here. Let me make my asymptotes green here just because the ones above are red, and that graph's kind of bleeding over now. So normally I would have had another asymptote if I added pi, but this time it'll come even faster. It'll come in pi halves, so it's like right here and right here. So I know this is awful. It's just I don't know what to do. This is the only thing I can use on this iPad to graph. All right, so normally, let me draw in blue what we would have now, okay? We would have, on the secant, it normally would be here, and it would go up, and then it would finish here, okay? And it would be up, and it would finish, oh, this one's wrong right here. Let me just scribble that out. I know that's going to be awful. This one should have been down here. So this one also would be down here at where negative 1/2's the high. Now we got to shift everything pi to the right, because remember this minus pi means pi right. So let me pick another color that will be easy to kind of track. Let's just use kind of a salmon pink color. So if this is 0, let's move this pi right. If it's 0, that means that one would actually be here. The thing about it is, since the period is pi and we're shifting right pi, we're going to be moving stuff like this one down here. I'll put a pink dot on it. It's actually going to move over here, but everything's just going to get shoved right on top of where it used to be, if you know what I'm saying. It's like because we're moving everything pi and the period is pi, it ends up being this exact same graph, because even though each individual one would shift over pi, the one that would have been on the other side of it comes in and fills up that space where that one would have been that got moved, if that makes any sense. So here would be my final graph on 19. Okay, so I thought we'd do number 23, y equal 2 cotangent x minus pi halves. And instead of trying to flip the tangent, it just gets so crazy. Let's just start. This is my graph of y equal cotangent x. And so let's graph it by using what we know and shifting this graph. I think it'll make our lives a lot easier to do that after trying 19 both ways. Okay, so here's our graph. We know that our amplitude is changed out front, and here's where that's going to get affected. Let me pick a color that'll show up. Right here, halfway in between at pi, at pi over 4, tangent, that's 45 degrees. The tangent is 1. So right here, this would be the point 1 on our graph. But all that's going to get changed here is that instead of maybe labeling that 1, I could label that 2 and that negative 2. And I'm still going to have the same basic shape of my graph. So that's good, okay? That's a quick thing to adjust is the amplitude. Now my period doesn't get changed because there's no number in front of this x here. So my period is still going to be pi. And again, that's pi for cotangent and for tangent. Everything else is 2 pi, okay? So those are the ones that are different. Normally, I would have a asymptote at pi. Let me put some numbers in. And I'd have another one at 2 pi. I'd have one at 0. I'd have one at negative pi. I'd have one at negative 2 pi. My period's still going to be the same, but everything is getting shifted. If you look here, this means right pi halves, which is basically right 90 degrees, okay? So if I would have had one at pi, it's going to get shifted here. And if I had one at 0, it's going to get shifted to 90 degrees here. If this one was here, negative pi, it'll get shifted to negative pi over 2. Negative 2 pi would get shifted here. So this one's not quite as hard to graph as maybe some of the other ones we've seen. Now, so I've got my asymptotes, and that's the hard part, because the good thing about it is halfway in between each of those asymptotes, the graph's going to go through 0. So I'm going to graph in green. So I can know, like, here's going to be, I'm going to be passing through those points. If you remember, 45 degrees increments will be here and here. So for instance, I'm going to do something like this. And then I'll be up here and then here, so I can draw these little branches in. And this one's going so nicely compared to the cosecant one on number 19, so much easier one. So basically it's halfway in between the asymptote and the 0. You're hitting 2 instead of 1. And so I can kind of draw this graph. And oh, that one went so much better.